This is the leaving water end and the single point power junction box end of the chiller. The video now moves down the front of the array. This is a slave front module. The next module is the master front module, and then we move past the remote panel and the first and only free cooling module. This is the pump module, and in the background you can see the storage tank and dual basket strainer module. This end of the unit is the return water connection and the C1 interface for the remote panel. We'll pan around to the left and you'll see the convenience outlet connection. Look down the walkway, and to the left you see the dual basket strainer. This is the return water connection coming back from the building load. It leaves the strainer and goes into the top of the 160-gallon storage tank. We take suction from the bottom of the storage tank to help us with suction pressure for the pumps. This is the pipe that goes over to the pump inlet. We'll pan up to see the pump discharge. You see those headered together and then entering the free cooling module. We'll pan down the rear of the array. You'll see the line coming from the leaving end along the bottom up into the tank. That is a bypass line. See the two rear mechanical modules, and now we'll pan right to see the glycol feeder and the expansion tank. Chillers of this type in recent design have gone to a 5-gallon mini glycol feeder. We're using the large glycol feeder here for consistency with the existing chiller at this post. One benefit of the new design with the mini feeder is it allows those components to be placed above the pumps and save a module space. We now pan to the leaving connection. You see the brass balancing valve and the bypass line that goes to the storage tank. There is an additional balancing valve installed where that red section of factory piping is. This allows us to balance and get the correct amount of water flow to the load and bypass the remainder back to the tank. This view from the leaving end shows the diagonal line that provides water to the rear module entering header. You'll notice the manual isolation valve on that diagonal line, as well as an additional isolation valve on the lower pipe. This allows us to isolate the front from the rear mechanical modules. In this view, we've moved into the walkway and will now pan down toward the free cooling module. You can see in the lower part of this shot the bypass line that feeds water to the rear mechanical modules. Now as we pan around, you'll be able to see where water comes in from the pumps and then routes into the free cooling module via the three-way valve if temperatures are appropriate. And then in this T and 90-degree turn, water either enters the first mechanical module or is bypassed to the rear mechanical modules. We'll now take a look at this water flow from the other perspective. Water enters from the dual basket strainer into the 160-gallon storage tank, leaves from the bottom. You'll note the T in from the glycol and expansion tank. Now into the pump module where it splits for the primary and standby pump. We'll pan up to see the water headered together and then turn down entering the free cool module. The top header entering the free cool module runs into a balancing valve, ensuring we get adequate water flow into the free cooling coil. This is the point where water is bypassed through the smaller header, down the diagonal path and into the top header of the rear modules, and then we follow back to the rear modules and their blank flanges. This final close-up view of the leaving connection shows the leaving thermometer, leaving pressure sensor, and the close-up of the leaving water temperature sensor well. This ties back to the master controller. This view is of the single point power junction box. There are 4 breakers for the mechanical modules, 1 for the free cooling module, an additional 1 for the pump module, 1 for the C1 panel, and the 8th one is for the Glycol Feeder module. This single point power junction box has a door interlock disconnect switch as well.